So welcome back. My name is Chris Nani, and today I want to take you through the design of a beam, a continuous beam. Actually, I want to see how to design a continuous beam in Tekla TEDS. I'm using Tekla TEDS 2018, but you can get the latest version is available now. So there are actually two methods or two ways of doing so. The first one, let me first start. So the first one is we can analyze and then we get the shear, maximum shear and the moment and use them in the design. You first do analysis and design, and then you do design. And then there is one where you can just run analysis and design at the same time, which I prefer because it is way shorter and quicker. So let us start with the first one. So the analysis. So we go to beam analysis. I'm using the British standard. So double click on the British standard of the BS. So my computer is a little bit slow because it is a Core 3, a Dell Core 3. It's not that cool, it's a bit slow. So, but yes, I'm sure it has already loaded. So you want to draw or want to come up with a sketch of our beam here. So the first thing, so make sure like this one, I want it to show the length. Then material, I'm going to use so we have there the BS lightweight, BS 8110 normal. So I'm going with the BS concrete, BS 8110 normal. So let us begin. So I want to enter 3.5. The first element of the beam will be 3.5 meters. Then let me set that. Let me use the rectangular. We have the circular, rectangular, flanged T and flanged L. I'm going the rectangular. Then I want it to be 300 millimeter width by depth of 200. So the name, the area. So the software calculates for you the second moment of area. I mean the inertia automatically, shear area, in my direction, and so let's begin. So the start and the end support you can change. You have free, pin, fixed, roller, all that. So let me go with the pin one. Then let me go with again 3.5, the second element. Then the last one, let me go with the 3 meters. 3 meters, 3.5, like that. So you can see I have the first one is 3.5, 3.5, and again 3 meters. Now we go to the loading. Now I'm going to load just per element. So the self weight will be automatically calculated because you have provided the length, you have the width, you have the width and the depth of your column, and the density of concrete is known. So this will be generated automatically. So if you want to add, so you have the self weight, permanent and imposed. So if you want to add anything like the wind load, snow, roof imposed, all that you can just add a load case here. But for me, I just want these three, so I'm going to select this one and delete it. You can delete it or you can leave it, you can just deselect here. So I'm going to provide the element load like this. We have a beam from here to here, so let me call it element 1, then this is element 2, then from here to here is element 3. So let me use element loads. So for element 1, if you're going the permanent load, it starts at 0 and ends at 1. Permanent load, let me use like 8 kilonewton. So normally you on your own you will have calculated, and kilonewton per meter, you already you will have done your calculations, and which values you have to use here at the permanent, imposed, and all that. So element 2 and permanent, let me use 10 kilonewton per meter. Then element 3, again I'm going to use this one. Let me use 5 kilonewton per meter. So 0 is at this point, like for element 1, 0 is at this point, 1 at this point. For element 2, 0 at this point, 1 at this point. So this one is supposed to be permanent. Then I repeat the same thing, but now for the imposed. Let me go with that 12. Then for element 2, let me go with Then for element 3, I will go with 10. So then I go to the load combinations. Now the load combinations are not important in the analysis, but they be more important normally in design. So if I want, I can add them my own. I can just click dead plus embossed. These are the ones that I want. Dead plus embossed. Then for the self weight, normally this will be 1.6 if I'm not wrong, then 1.4, then 1.6 again. Or if you don't know, you can just delete these ones. Yes, and you generate them automatically according to the BS. So this is, so I'll choose like this: 1.4 dead, 1.6 post, 1.6 self weight. Then I click next to confirm it. Then I click next to confirm it is okay. This is the service string, the service load. So load combination, I mean. So I click finish. Then I'm good to go. I can check the results. So it is okay. Everything is okay at the nodes, at the elements, at the members. Then you click on output because you want to see the results. So here I'm going with the load combinations. You can choose whatever you want. Elements, let me leave it to element. Then here I will be able to select what I want to appear. So let me go down to total deflections or what you want in your results, like in a PDF format. Then I will click OK. Everything is okay. Click OK. Then you have to wait for it to get the output. Yeah, my computer is a little. So here are the results. For me, what I want is the table. So the maximum. So here the bending and the shear diagrams. So the maximum moment on the span is 28.9, but at the support is we have 47, but on the span is 28.9. Actually on span 1, the first span. And then the shear, the maximum is 73.9. So you'll be okay. So then you can move to design. So after I know that I have 28.9 and the 73.9, I can move to design. So I can click on this new. Then I go to beams, RC beam design according to the BS. So I have the maximum bending moment. For me it was 28.9. Then shear it was 73.9 if I'm not wrong. And then beam details, it was 300, 200, and it was rectangular in shape. Cover, let me go with 20 on all the sides. Then the class of concrete, let me go with 30. Density of reinforced concrete, so you can change anything you want. Maximum aggregate size, you can change it okay. So no reinforcement required. You don't need compression, so everything is okay, but you can check to see. So if I use 20, the 20 will not be okay, so I'm going with 25. 20 will not be okay, so I'm going with 25. Then we have the number of shear legs. So here also you can play around with anything how you want it. Let me do it like this. So this is okay. Then I click on finish and I'm done. So this is okay. Now you can take this, you can export this document to Word, or you can just print it the way it is as a PDF. So the next method, I will come to new. I want to do analysis and design, so I'm going to beams, RC beam analysis and design according to the BS. I want to design a continuous beam. So you have a beam here, so you go to geometry. So geometry, so this was 3500. I add another span, just that add another span which is 3000. Then let me say okay. Yes, then loading. So loading, let's do the spans because we're doing the elements. We're going to do the loading at the span. So I add dead. For span 1, I think it was 8. Then span 1 begins at 0, ends at 3500. Then I add impost. For span 1 impost, I used 12. Begins at 0, ends at 3500. Span 2. For span 2, dead, I used it was 10. Impost was the impost load was 15. 3500. Span C, the dead was, I used 5. 0, this one was, so this is 0, this is the, and so the dead was my impost was 10. Was it 10 or 12? 10, 3000. I hope it was 10. So once I'm done, I hit OK. Then we go to the combinations. So this okay, 1.4, 1.4. Is this okay? Post okay. Then the load redistribution. So if you want, to can add the redistribution. It's not that necessary, but you can. So there is a clause here which explains actually what you're supposed to redistribute. Like here you can only redistribute 30%. Like here, if I've chosen 10, then here I can go with 20 or less than 20. But if I use more than 20, like 25, that's 35. When I hit OK, I will have this error. So it's supposed to be within, but you can distribute because yeah, you can just redistribute. But of course, you cannot redistribute at the start and end support. So let me leave it like that for now, so that it matches the first analysis. Then beam details. So here is 300 and this 200. Then here we're using 20. Cover was 20. The cover stand material details. Let me go. I was going with 30. It is 25. Yes, 30 plus 30. So if you check the redistribution, you can see it is 28.9, the maximum moment at the span. Like it matches the first term, which is okay. So I'm going to design at only span 1, which has the maximum moment. If you want, you can change. So I'm going with span 1 because it has the maximum. How do you know it has the maximum? You can click on the redistribution and you'll be able to see. So if you want to, then the section details design. On the section design, so this one don't have a problem with it because you don't need it anymore. Then this one 25. Then this one let me leave it to 2 and reduce the spacing to 100. Then I hit OK. So everything is okay so far. Design options, there's no need for this, so I click finish. So the analysis should be the same with the first method. It will actually be the same. The results will be the same, which is 28.9, and we have 28.9 and negative 47.1. but the first analysis it was just negative 40. The first analysis it was just negative 47. No, I think it's okay. It's okay. The design is actually also okay, and the last method is the fastest one. Please remember to subscribe for more videos. Thank you for watching.